These are sounds of our times. Called telemetry, it is the way satellites orbiting in space report to controllers on Earth. Each spacecraft has its own signature, a unique tone. Engineers call it data. You may see it later as a weather report or a television picture from around the world. Space down to Earth with application satellites. What they are, what they're doing for you now, and what will be happening in the decade of the 70s. Weather, communications, Earth resources. These will be among the main topics for dialogue in the 1970s. Each has its own type of impact on our lifestyles. At times, we will be more concerned about one than the other, but always they will be there. Case in point, weather. Spacecraft, like TIROS, Nimbus, and the application technology satellites. Satellites that return daily weather information over the entire world. What do they report? A continuous watch of the Earth's moving cloud cover, tracking storms, measuring winds, recording temperatures at different heights, and testing the moisture content of the atmosphere. As a result, computer systems are built that can receive and analyze vast amounts of global information from many sources, making forecasting more accurate. Hurricanes with their devastating winds and flood-causing rains, a perennial threat. In 1969, Hurricane Camille was first observed and then tracked by satellite. Because the storm's arrival was predicted accurately enough in advance, it was possible to evacuate people from the Gulf Coast. Without this early warning, the Weather Bureau estimated that 50,000 people might have been killed. In contrast, during Hurricane Laurie in November 1969, observations and tracking by satellite enabled the weather forecasters to predict that Laurie would not strike the coast. It is estimated that $3 million was saved from this satellite-prompted decision not to evacuate and not to protect property. TIROS, Television Infrared Operational Satellite. Over the past 10 years, 20 of these hatbox-shaped satellites have been successfully launched for use by NASA and the Weather Bureau. The television eyes of TIROS scan the entire globe daily, reporting on cloud cover and warning of major storms. Since the first operational weather satellites started clicking off pictures, roughly 600 severe storms have been detected, followed, and predictions made about their course. They have sent back more than 1 million pictures of weather conditions around the globe. Cameras on board the Applications Technology satellite scan the Earth and return color images as often as every 20 minutes. Here's a view showing 6 hurricanes on one picture. This near continuous surveillance of 40% of the Earth's surface has proven so useful that the reports have been incorporated into routine weather forecasts and have pointed the way for even more sophisticated meteorological satellites. Major airlines make use of satellite data in planning their flights. Pilots routinely receive weather photos of their transoceanic routes. Before satellite tracking of hurricanes, U.S. Navy hurricane hunters had to search out the killer storms. Weather satellites now locate the storms, and the Navy flies directly to them to make their measurements. The Navy also uses weather satellite pictures for ice patrols. Remote stations in the Antarctic benefit too. giant resupply ski planes can be safely scheduled for landings in the icy outposts without worrying about being trapped by snowstorms. Supply ships benefit from improved scheduling as well. A recent satellite in the TIROS series does the work of 2 spacecraft. Carrying twice as many cameras, it's capable of discerning cloud formations as small as 2 miles across. The improved TIROS operational satellite carries a proton monitoring instrument that helps spot solar flares. The same instrument can measure the amount of heat reflected from and absorbed by the Earth's atmosphere. This is very important in weather forecasting. In addition, radio frequencies affected by solar storms can be changed in advance, and manned flights to the moon better planned. Nimbus, research and development craft studying advanced techniques and concepts for meteorological Earth observations. Nimbus is measuring the atmosphere's temperature and moisture at various altitudes, as well as making day and nighttime cloud photographs. These measurements are considered the key to accurate long-range weather forecasts. By the end of this decade, forecasts made 1 week in advance will be as accurate as those now made 24 or 48 hours ahead. Satellites and weather are global in nature. Every nation in the world can benefit from the automatic picture transmissions of U.S. weather satellites. Over 50 countries are now using inexpensive automatic picture readout equipment to view daily weather patterns over their own territory. These same countries also benefit from cloud picture mosaics, routinely made available by the Weather Bureau to Europe, Asia, Australia, and North and South America. The weather mosaic is built up from individual weather photos and processed by computer. It is then retransmitted by a satellite. There are 3 main objectives for an effective meteorological program. The first, global cloud cover photography, enabling us to identify and track storms and to observe their formation and dissipation. This is valuable in the analysis of current weather and the prediction of 24 to 36-hour changes. The second objective, continuous viewing of the atmosphere, needed to keep significant portions of the Earth's cloud cover under constant surveillance and providing essential early warning on rapidly developing weather phenomena, such as thunderstorms and the formation, growth, and death of tornadoes. This information is valuable for short period forecasts of less than 12 hours. The third objective, a global atmospheric research program. Its goal, long-range weather prediction on a worldwide basis. In 1976, scientists from governments, industries, and universities in many countries will meet to work out the problems of international weather forecasting. The global research program will use computers to design and test theoretical models of atmospheric behavior. When the mathematical models are combined with information returned from already operating satellites, it may be possible to make forecasts 2 to 3 weeks in advance. Communications. Some of the greatest strides in putting space to work have taken place in this field. In 1960, Americans made 100 billion telephone calls. In 1969, nearly 200 billion were made. New uses are continually being found for telecommunications. Banks, stock exchanges, hotel reservations, cable TV, hospitals, computer centers, and other new customers are appearing at an increasing rate. We are in the midst of a global communications explosion. Helping meet this demand are communications satellites.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as ECHO.
August 12, 1960. President Eisenhower took part in the historic first transmission via ECHO satellite. By bouncing radio waves off its shiny surface, it made possible long-distance telephone conversations and the transmission of photographs and music. Other communication satellites followed: Telstar, Relay, Syncom, each a research step leading to commercial spacecraft capable of handling satellite communications. In 1964, television viewers around the world were able to watch the Olympics from Tokyo. A visit to Mexico City by the Pope was also viewed globally. Over 500 million people, 1/6 of the world's population, saw man's first steps on the moon. Color coverage of space recovery operations from mid-ocean is now routine. At the Manned Spacecraft Center in Houston, doctors discussed space medicine and early cancer detection. The proceedings were telecast live via communication satellite and provided two-way voice circuits between the United States and 3 European countries. The closed-circuit telecast enabled 30,000 European doctors to hear the 3-hour transatlantic conference. One of the best ways to check out new concepts and techniques in communications, navigation, and meteorology is with research and development spacecraft. The applications technology satellites are just that, serving as platforms for testing out new concepts in all these disciplines. The ATS program consists of 7 flight missions. 5 of these have already been flown. Probably the most unique characteristic of the ATS is their ability to receive and transmit from a number of widely separated ground stations simultaneously. They can handle telephone calls, transmit television, teletype, radio voice, and weather data all at the same time. Keeping in contact with the SS Santa Lucia as it steamed between New Jersey and Chile, ATS demonstrated the feasibility of using satellites for high-quality, reliable ship-to-shore communications over long distances. A similar test was made with a U.S. Coast Guard ship. ATS has been used to relay information from remote instruments and buoys, a step toward future data relay satellite systems. A successful experiment to transmit television by satellite from the east to the west coast took place with the help of the Corporation for Public Broadcasting.
These current tests are enabling NASA and the broadcasting community to iron out technical problems that are involved in this form of transmission and to determine the costs of such future operations. If these tests are successful, and we have every reason to believe that they will be, the American people will reap a major domestic dividend from the national space effort.
The program was relayed from a ground station in Rosman, North Carolina, through the ATS to KCET-TV, the educational station in Los Angeles. As soon as the receiving equipment is operating, Alaskans will have educational radio and television programs beamed to their state. Through an agreement signed with India, an applications technology satellite, similar to the one shown in this artist's concept, will begin telecasting instructional television into 5,000 Indian villages by 1974. India will provide the TV programs. The results of this cooperative experiment are expected to provide an understanding of the effectiveness of satellite systems in meeting the needs of other developing countries. A satellite-to-satellite laser communications experiment is also planned on future ATS spacecraft. Beams emitted by a laser can carry immense quantities of information. communication satellites hold great promise for navigation and traffic control. Today, airplanes flying over wide open areas of the oceans are out of radio range for periods of an hour or more. The problem is compounded by the fact that most airlines going to Europe from New York, for instance, want to depart at 6 p.m. to serve dinner and show movies. They also want to go to the same altitude to take advantage of favorable tailwinds. The problem then of keeping international air traffic sufficiently spaced becomes more and more serious. NASA has been experimenting with a system to determine the position of planes and ships. The system makes it possible for a ground-based station to automatically locate aircraft and ships equipped with receiving and transmitting equipment.
Gunner Mobile number 2, Pan Am Slipper 271. Position here from INS readout is 31 degrees, 32 minutes north, 70 degrees, 1 minute west. Flight level 330. This is 271, over.
In recent tests, position accuracies of less than 1 mile error have been achieved. Results of this work could lead to advanced techniques for satellite position fixing and traffic control, and aid in the solution of some of the world's transportation problems. Space geodesy has taught us the true shape of our planet, where it flattens, how much it bulges. With these results, we are better able to map the Earth and to navigate. The orbital path of a satellite is not a perfect circle. The satellite weaves sideways and up and down as it travels its course around the Earth. These deviations are measured only in feet, but they can be detected by Earth-based tracking stations and reveal new facts about the Earth's structure. Satellites have been tracked by laser. After predicting where spacecraft will be at any given time, telescope-mounted lasers swing into position, and aided by computers, their pulses of light lock on and track the orbiting craft. 3 of NASA's Explorer satellites carried special reflectors that mirrored the laser light flashes. The positions of the satellites were precisely determined, and the distance calculated simply by measuring the time it takes the beam to go to the satellite and return. Precision in satellite tracking leads to precision in terrestrial mapmaking. The Department of Interior estimates that the value of up-to-date topographic maps is worth nearly $700 million annually to our national economy. On the North American continent, surveyors have laid out a grid enabling them to locate any point with respect to another within 30 feet. There are similar grids in other well-developed countries, but they are not tied together. A surveyor cannot see over the ocean with his transit to make the connections. But a satellite can. It is a valuable tool because of its altitude. Observers several thousands of miles apart can see a high-flying satellite at the same time. By making simultaneous measurements with optical and radio tracking instruments, they can determine just how far apart they really are. The current goal of satellite geodesy is to tie all geodetic grids together to within an accuracy of 30 feet. Using high-flying satellites as geodetic markers, the world's continents will eventually be tied together to one common reference system. Geodesists also hope to use their new techniques to keep track of polar ice caps and glaciers, monitor the geometry of the ocean surfaces, increase knowledge of how earthquakes occur, and make direct measurements of the rates of continental drift. As the world's population continues to grow, our need to develop, protect, replenish, and use our natural resources wisely becomes more apparent and urgent. The air and atmosphere are resources of the Earth, as are the oceans, fresh water, ice packs, forests, minerals, and usable land. Efficient utilization of these resources not only includes their discovery and management, but also detection and control of pollution. In many areas, this need is reaching crisis proportions. Concerned citizens, private industry, state and federal agencies, all are seeking solutions to the problem. New techniques are being discovered to help. NASA has been exploring the use of both manned and automated spacecraft to develop the potential of flying instruments in space that will permit unique observations of the condition of our agricultural, water, forest, mineral, land, and marine resources. Much research has been done with aircraft, with information from existing satellites, and of course from the valuable photographs taken by the astronauts of the Mercury, Gemini, and Apollo programs. Based on this experience, it appears that the vantage point of space offers a number of unique possibilities for surveying Earth resources. The first two unmanned Earth resources satellites are planned for launch, one in 1972 and one in '73. They will provide a regular timber inventory of the Earth, identify crops, their vigor and yield, make automatic soil classifications, take photographs of the sedimentation flow patterns of the world's waterways, and help in locating mineral deposits. Here are some views recorded from planes and from Earth orbit by spacecraft. Better surveys of food and forest areas can be made from space, with computers distinguishing the conditions of the various types of crops and soils. Infrared photographs can show the onset of insect disease in forests. The damaged trees show up blue-green in color, the healthy trees red or pink. An Apollo spacecraft orbiting 150 miles over northern Australia spotted forest fires. Here are two others, as seen from space southwest of Tallahassee, Florida. By viewing fresh water from space, lake colors can be correlated with the biological, chemical, sediment, and pollutant content. Glaciers are another important source of fresh water, and their growth and decline are very sensitive indicators of the available supply. The Bureau of Commercial Fisheries says there is a close relation between fishery production and the temperature of the ocean, and they're very interested in having more accurate spaceborne instruments developed for monitoring these thermal conditions. This could significantly improve the efficiency of fishing fleets. Space photography can assist in mapping navigation routes in coastal and shoal water areas and help control silting in major harbors and navigable rivers. Ultimately, spaceborne instrumentation may permit observations of the wave heights of our oceans. Although it will not be possible to acquire all of the needed Earth resources data by sensors located directly in the satellites, it is possible to supplement the information by placing surface instruments, such as buoys, water gauges, and strain gauges, at strategically located positions on the surface of the Earth. These surface instruments could transmit the data to satellites, which would then relay it to central data handling stations. The Nimbus weather satellite is playing a role in ecology right now. A recording system on Nimbus was developed for an animal tracking experiment. Scientists attached a specially instrumented collar on an elk in western Wyoming. As Nimbus flies over, it receives information about the elk's condition and location and reports back to Earth. Accurate tracking of free-roaming animals in their natural environment will increase scientific knowledge of animal migration habits and may show ways to help protect our wildlife population. This is Skylab, America's first manned experimental space station. It will be launched into orbit around the Earth in 1972. There are several Earth observation experiments planned for the orbiting space station. One of the men who hopes to be flying in Skylab is scientist-astronaut Dr. William Lenore. He too is interested in Earth resources.
One of the more interesting aspects of what we can learn from space, I think, is the Earth resources area, which generally is tied up in the kind of things that I can learn from space by being in Earth orbit, looking back at the Earth from a remote sensing point of view. Meteorologically, we've seen many things already. We can learn about the Earth's surface from a crop survey standpoint, where the surface water is and the immediately subsurface water for the water management for the world. Pollution control and studies as to where the pollution is being emitted from and where it goes to. Fish industries for the ocean and sea states for ocean-going vessels, icebergs. I think these are just actually very few of the types of things that we can monitor and study from space on Earth's resources. The Skylab program is going to be stepping off in this direction.
Bringing space down to Earth continues to make a substantial impact on our way of life. Communications satellites routinely provide reliable telephone service on a global basis, and important events are brought into our living rooms through intercontinental television. Coming close to reality, satellites that broadcast news, educational and cultural programs to populations of entire nations. Meteorological spacecraft aid in daily weather predictions. Satellites for navigation and traffic control will help make better economic and safer use of air corridors and oceans. Earth surveys from space should offer another means of preserving natural resources. We are sharing many benefits from space right now. As we develop this potential in the future, applications from space will have continued, profound, and direct effects on our everyday lives here on Earth.